Right now, at this very moment, you're looking at light that has been traveling for years. Not hours, not days, years. And here's the thing that's going to break your brain by the end of this video. When you truly understand what that means, when you really grasp the distance light travels in a single year, you'll never look at the night sky the same way again. Stick with me until the end because I'm going to show you something that will fundamentally change how you see your place in the universe. And trust me, you'll want to see where this goes. Let's start with something you understand perfectly. Distance. You know exactly what 5 kilometers means. That's about a 10-minute drive, maybe a 30-minute walk. You can picture it in your mind. You know the landmarks you'd pass, the streets you'd cross, how long it would take. Now let's go bigger. The distance from New York to Los Angeles? About 4,500 kilometers. That's a 5-hour flight. You've probably made a trip like that, or you know someone who has. It's far, sure, but it's comprehensible. It fits inside your brain. You can hold that distance in your mind and understand it. Even Earth's circumference, 40,075 kilometers, is something we can work with. Early explorers sailed around the world. It took them years, but they did it. The Earth is big, but it's not incomprehensibly big. It's finite. You could, in theory, walk every inch of it if you had enough time. But here's where things start to fall apart. The Moon is 384,000 kilometers away. Now stop for a second. Really try to visualize that distance. Can you? Probably not. Your brain sees it as a really big number, but you don't have any intuitive sense of what it means. There's nothing in your daily life that prepares you for a distance like that. The Apollo astronauts, traveling at speeds 400 times faster than highway driving, took 3 full days to get there. 3 days of flying through space at 39,600 kilometers per hour just to reach something we can see with our naked eyes every night. And that's just the Moon, our closest celestial neighbor. The Sun is 150 million kilometers away. Try to picture that. You can't, can you? Your brain just refuses. It's too big, too abstract. The fastest spacecraft humanity has ever built, the Parker Solar Probe, traveling at 192 kilometers per second, still takes months to cover that distance. Months. And the Sun is right here. It's in our cosmic backyard. We orbit around it. We see it every single day. When we start talking about other stars, even our Sun's distance becomes laughably small. Proxima Centauri, the nearest star beyond our Sun, is 266,000 times farther away than our Sun. Let me say that again. 266,000 times farther than a distance that already takes our fastest spacecraft months to cross. This is the moment when kilometers stop working. The numbers become so large that they lose all connection to reality. They stop being distances and become just numbers. Abstract, meaningless, impossible to grasp. We need something different. Something that works at these impossible scales. Something that can help our tiny human brains comprehend the incomprehensible. We need the light year. But before we can understand what a light year really is, we need to talk about light itself. Because light isn't just fast. Light is the key to unlocking the entire universe. Light is special. And I don't mean that in some poetic, romantic way. I mean, it's fundamentally, physically, cosmically special in a way that nothing else in the universe is. Light travels at 300,000 kilometers per second. Every single second, light covers 300,000 kilometers. Let that sink in for a moment. In the time it takes you to snap your fingers, light could travel around Earth's equator 7.5 times. In 1 second, light could go from New York to Los Angeles and back 37 times. It's a speed so fast that nothing in our everyday experience even comes close. The fastest commercial jet flies at about 900 kilometers per hour. Light travels over 1 million times faster than that. The fastest car ever built? Light is 900,000 times faster. Even our fastest spacecraft, the Parker Solar Probe I mentioned, traveling at 192 kilometers per second at its absolute peak, is still crawling compared to light. It's moving at only 0.064% of light. But here's what makes light truly special. It's not just fast. It's the fastest thing possible. Nothing in the universe can go faster than light. And this isn't a challenge we haven't overcome yet, like breaking the sound barrier or reaching the moon. This is a fundamental law of physics. It's built into the very fabric of reality itself. Einstein showed us why in 1905. As you approach light speed, strange things happen. Time slows down for you. Your mass effectively increases. The energy required to accelerate you further approaches infinity. To actually reach light speed would require infinite energy, which the universe simply doesn't have. Therefore, nothing with mass can ever reach light speed. It's impossible. Not difficult? Not, we haven't figured it out yet. Impossible. The only things that can travel at light speed are massless particles, photons, particles of light, and they don't have a choice. They must always travel at exactly this speed. From the moment they're created to the moment they're absorbed, they move at 300,000 kilometers per second. No faster, no slower. Now here's something fascinating. For most of human history, people didn't know light had a speed at all. You open your eyes and you see things instantly, right? So it seemed like light must travel instantaneously, infinitely fast, appearing everywhere at once the moment it's created. But in 1676, a Danish astronomer named Ole Rømer was studying Jupiter's moons when he noticed something weird. The times when these moons disappeared behind Jupiter kept changing. When Earth was closer to Jupiter, the eclipses happened earlier than predicted. When Earth was farther away, they happened later. Rømer realized this wasn't because Jupiter's moons were misbehaving. It was because light took time to travel the different distances. He calculated that light took about 22 minutes to cross Earth's orbit. His numbers weren't perfect because he didn't know the exact size of Earth's orbit, but he proved something revolutionary. Light has a finite speed. Today we've measured it with extraordinary precision using lasers and atomic clocks. We know it's exactly 299,792.458 kilometers per second. For simplicity, we round to 300,000. And we've discovered something even more profound. This speed limit isn't arbitrary. It's a fundamental constant woven into space-time itself. It defines the relationship between energy and matter, between space and time, between cause and effect. This is why the speed of light becomes our measuring stick for the cosmos. When you're dealing with distances so vast that normal units become meaningless, you use the one thing that's constant everywhere in the universe, the one thing that never changes, no matter where you are or how fast you're moving. You use light. And when you multiply light's speed by time, something remarkable happens. You create a unit of distance that's perfect for measuring the cosmos, a distance that fundamentally connects space and time. You create a light year. A light year is not a measure of time. I know it has the word year in it, which makes it sound like time, but it's not. A light year is a measure of distance. It's the distance that light travels in 1 year. Let me show you how we build this distance step by step, starting small and watching it grow into something that will absolutely break your brain. 1 light second. That's 300,000 kilometers, the distance light travels in a single second. To put that in perspective, that's roughly the distance from Earth to the Moon and 3/4 of the way back, all in 1 second. When astronauts on the Moon talked to Mission Control during the Apollo missions, there was a 1.3-second delay each way. They'd say something, and Houston wouldn't hear it for 1.3 seconds because the radio signal, traveling at light speed, needed that long to make the journey. Then Mission Control would respond, and that response would take another 1.3 seconds to reach the Moon. Every conversation had this built-in pause, this lag, because of the distance the signals had to travel. Now let's scale up. 1 light minute is 60 light seconds. That's 18 million kilometers. The Sun is about 8 light minutes away from Earth, which works out to roughly 150 million kilometers. So when you look at the Sun, assuming you're not foolish enough to stare directly at it, you're seeing it as it was 8 minutes and 20 seconds ago. If the Sun exploded right now, we wouldn't know for over 8 minutes. We'd just keep seeing the Sun shining peacefully in the sky, completely unaware that it was already gone. This has practical implications that most people never think about. When NASA operates rovers on Mars, every command takes between 3 and 22 minutes to arrive, depending on where Mars is in its orbit. If the rover encounters a problem, if it gets stuck on a rock or starts sliding down a slope, the engineers on Earth can't react in real time. They have to wait for the signal to reach Earth, analyze what went wrong, write new commands, send them back, and wait again. A problem that would take seconds to fix with a remote control car on Earth can take over an hour to solve on Mars. 1 light hour is 60 light minutes, about 1.08 billion kilometers. Saturn, that beautiful ringed world you can see with a telescope, is about 1.2 light hours away at its closest. When the Cassini spacecraft was orbiting Saturn, taking those incredible close-up photos, there was over an hour of delay between when it took a picture and when scientists on Earth received it. They couldn't control Cassini in real time. They had to program entire sequences days or weeks in advance and trust the spacecraft to execute them. 1 light day is 24 light hours, about 26 billion kilometers. Voyager 1, launched in 1977, and now the most distant human-made object from Earth, is roughly 1 light day away. Think about that. It's been traveling for nearly 50 years at 17 kilometers per second, fast enough to cross the United States in 2 minutes, and it still hasn't traveled even 1 full light day from home. Keep going. 1 light week is 7 light days, about 181 billion kilometers. Out here, nothing human-made has ever been. The Sun would appear as just a bright star among thousands of others. You'd realize, perhaps for the first time, that our Sun is just one star among many. 1 light month is roughly 30 light days, about 778 billion kilometers. At this distance, even with a powerful telescope, our solar system would be barely visible. Everything we know, all the planets we've studied, would be compressed into a tiny region around an ordinary star. And now, finally, we arrive at 1 light year. 1 light year is 365 light days. It's 8,760 light hours. It's 525,600 light minutes. It's 31,536,000 light seconds. See how quickly the numbers explode? We started with 1 light second, already an enormous distance, and we've been multiplying by 60, by 24, by 7, by 52, and we're just now getting to 1 light year. 9.46 trillion kilometers, 9,460,730,472,580 kilometers to be precise. But we usually just say 9.46 trillion. Now here's the problem. You have absolutely no intuitive sense of what a trillion actually means. None of us does. Our brains didn't evolve to comprehend numbers this large. Let me help you understand. 1,000,000 seconds is about 11.5 days. That's conceivable. Less than 2 weeks. You can imagine that time span. But 1 billion seconds? That's 32 years. If you started counting seconds when you were born and never stopped, never slept, never ate, just counted continuously, you'd be 32 years old when you reached 1 billion. Now 1 trillion. If you counted to 1 trillion, 1 number per second, it would take you 31,700 years. That's longer than all of recorded human history. Agriculture was only invented 10,000 years ago. Writing systems appeared 5,000 years ago. To count to 1 trillion, you'd need to have started counting when humans were still living in small tribal groups during the last ice age, hunting woolly mammoths with stone tools, and you'd still be counting today. And you'd still have thousands of years to go. And a light year is 9.46 trillion kilometers. Not trillion meters. Not trillion centimeters. Trillion kilometers. Each one of those kilometers is a distance you could walk in 10 to 12 minutes. And there are 9.46 trillion of them in a single light year. This is the unit astronomers use to measure the universe. Because nothing smaller makes sense when you're talking about the distances between stars. So now that we've built this impossible distance, this measurement that challenges everything our brains know about scale, let's use it. Let's see what exists at these distances. Let's explore our cosmic neighborhood and discover just how alone we really are. Proxima Centauri is 4.24 light-years away. That's our nearest stellar neighbor, the closest star to our Sun, and it's 4.24 light-years away. Let that number settle in your mind for a moment. Remember what we just learned. 1 light-year is 9.46 trillion kilometers. Multiply that by 4.24 and you get roughly 40 trillion kilometers. 40 trillion kilometers to the nearest star beyond our Sun. If you could somehow travel at the speed of our fastest spacecraft, the Parker Solar Probe at 192 kilometers per second, it would take you 6,800 years to reach Proxima Centauri. That's longer than all of recorded human history. You could have started your journey when humans first invented writing, traveled continuously at the fastest speed any human spacecraft has ever achieved, and you still wouldn't have arrived yet. You'd still be traveling through space, still thousands of years away from your destination, and that's just to reach our closest neighbor. Proxima Centauri is a small red dwarf star, about 1/8 the Sun's mass. It's so small and dim that despite being our nearest stellar neighbor, you can't even see it with your naked eye. You need a telescope. The closest star to us is invisible without technology. Think about what that means. The stars you see at night, every single one of them, is farther away than Proxima Centauri. Every point of light in the night sky that you can see without a telescope is more distant than our nearest neighbor. Within 20 light-years of Earth, there are only about 130 known star systems. In a sphere 20 light-years in radius, a volume of space so vast it would take 20,000 years to cross with our current technology. There are only 130 stars. The universe isn't crowded. It's not teeming with stars packed close together as you see in science fiction movies. It's mostly empty, vast stretches of nothing punctuated by tiny islands of light. Barnard's star, the second closest star system, is 6 light-years away. Sirius, the brightest star in our night sky, is 8.6 light-years distant. It looks bright, not because it's close, but because it's intrinsically very luminous, and it happens to be relatively nearby. When you look at Sirius tonight, you're seeing light that left that star 8.6 years ago. You're seeing Sirius as it was when you were almost a decade younger. Wolf 359 is about 7.9 light-years away. Vega, another bright star you can easily spot, is 25 light-years distant. If you're 25 years old and you look at Vega tonight, you're seeing light that began its journey the year you were born. When that light started traveling toward Earth, you didn't exist yet. This is our cosmic neighborhood. This is what exists within walking distance, so to speak, of our solar system, and it's almost empty. The distances between stars are so vast that even our nearest neighbors are impossibly far away. We're not living in a cosmic city with neighbors on every corner. We're living in the cosmic equivalent of a remote farmhouse in the middle of nowhere, with the nearest neighbor dozens of miles away down a road we can barely see. And here's what really breaks your brain. This isolation is normal. This is what the universe looks like everywhere. If you were transported to another star in another part of the galaxy, you'd see roughly the same thing. Stars scattered at light-year distances, separated by vast gulfs of space. The universe is structured this way, light-years of nothing between tiny points of light. There's something profoundly lonely about this realization. We're isolated not by choice, but by the fundamental structure of space itself. The distances are so vast that meaningful contact or travel becomes almost impossible. We can see our neighbors. We can study them with telescopes. We can send them radio signals that will take years to arrive. But we can't visit them. We can't call them up for a chat. We can't pop over for a visit. We're here, on this small planet, orbiting an ordinary star, with the nearest other star 4.24 light-years away. And that distance, that light-year measurement, is a barrier that might be fundamentally insurmountable. But it gets even stranger. Because those light-years don't just separate us in space, they separate us in time, and that changes everything. Here's where things get truly mind-bending. When you look at a star, you're not seeing it as it is right now, you're seeing it as it was. You're literally looking into the past. Betelgeuse, that reddish star in the constellation Orion, is about 550 light-years away. The light you see from Betelgeuse tonight started its journey in the year 1474, during the Italian Renaissance, before Columbus sailed to the Americas, when Leonardo da Vinci was 22 years old. That light has been traveling through space for over 5 centuries to reach your eye tonight. And here's the thing that should genuinely disturb you. Betelgeuse is a massive star nearing the end of its life. At some point, probably within the next 100,000 years, it's going to explode as a supernova. When it does, it will briefly shine as bright as the full moon in our sky. It'll be visible during the day. It will be spectacular. But Betelgeuse might have already exploded. The explosion might have happened in 1700, 1800, or 1950, and we wouldn't know. We wouldn't have any way of knowing. The light from that explosion is still traveling toward us, still 550 years away from arrival. We could be looking at a star that's already dead, seeing a ghost, an image of something that no longer exists, and we won't know the truth until the light finally arrives. Distance and time are inseparable at these scales. You cannot separate where something is from when you're seeing it. Now let's talk about communication, because this is where the isolation becomes truly profound. Radio waves travel at the speed of light. They're the fastest way we have to send information across space. And even at light speed, communication across light years takes years. Imagine we detect a signal from an alien civilization on a planet orbiting a star 50 light years away. That signal we're receiving was broadcast 50 years ago. We're hearing their transmission from half a century in the past. If we respond immediately, our response takes another 50 years to reach them. That's a 100-year round trip for a single exchange of messages. You could ask a question and die of old age before receiving an answer. Your grandchildren might hear the response to a question you asked. There can be no conversation in any normal sense of the word. No dialogue, no back-and-forth negotiation, no real-time communication whatsoever. For Proxima Centauri at 4.24 light-years, you're looking at an 8.5-year wait for any reply. For a star 100 light-years away, it's a 200-year communication delay. You send a message, and neither you nor your children nor your grandchildren will live to see the response. Only your great-great-great-grandchildren living in a world you can barely imagine might hear back. This has staggering implications for the Fermi paradox. You know the question, if the universe is so vast, with billions of potentially habitable planets, where is everybody? Why haven't we detected alien civilizations? Maybe the answer is simpler than we think. Maybe they're out there. Maybe the galaxy is full of civilizations. But they're all separated by light years. Dozens of light years, hundreds of light years, thousands of light years. At these distances, even detecting each other becomes nearly impossible, and communication becomes pointless. Think about it. We've only been broadcasting radio signals for about a century. Those signals have reached all stars within roughly 100 light-years, but the Milky Way is 100,000 light-years across. We've announced our presence to a tiny bubble of space, a fraction of a percent of our galaxy. And those signals are getting weaker as they spread out, dispersing over larger and larger spheres. By the time our broadcasts reach a star even 50 light-years away, they're so faint they'd be almost impossible to detect above background noise. Maybe the universe is full of civilizations, all broadcasting, all listening, but none of them hearing each other because the distances are simply too vast. Ships passing in the cosmic night, forever isolated by light years they can never cross. Each civilization develops alone, asking questions alone, making discoveries alone, and eventually dies alone, never knowing if anyone else was out there. The light year doesn't just measure distance. It measures isolation. It measures the barrier between us and anyone else who might exist in this vast, empty cosmos. And that barrier might be permanent. So what does all of this mean for us? You are standing on a small planet, orbiting an ordinary star in a galaxy containing hundreds of billions of other stars, in a universe with trillions of galaxies. The nearest star beyond your sun is 4.24 light-years away, a distance so vast it would take thousands of years to cross with our current technology. And you are seeing that star, and every star in the night sky, not as they are, but as they were, looking back through years or centuries with every glance upward. From a cosmic perspective, you are utterly insignificant. Your entire life, maybe 80 or 90 years if you're lucky, is a brief flicker in a universe that's 13.8 billion years old and will continue for trillions of years more. You exist on a tiny world that's invisible from even our nearest stellar neighbor. Everything humanity has ever done, every civilization that's ever risen and fallen, every war fought, every discovery made, all of it has happened on one small planet in one small corner of one typical galaxy. But here's the paradox that should take your breath away. You're also extraordinary. You are made of atoms forged in the hearts of stars that died billions of years ago, stars that exploded, scattering their matter across space, matter that eventually coalesced into new stars and planets, and, ultimately, into you. You are literally made of stardust. Every atom in your body, except for hydrogen, was created in the nuclear furnace of a star or in the explosion of a supernova. You are the universe experiencing itself, a way for the cosmos to know itself, to understand itself. And you figured this out. Despite being a tiny creature on a tiny planet, you measured these vast distances. You calculated light years. You understood that Proxima Centauri is 4.24 light-years away, that Betelgeuse is 550 light-years distant, that the observable universe stretches 93 billion light-years across space. You built telescopes and spacecraft and developed mathematics that allowed you to comprehend things billions of light-years away. That's remarkable. That's powerful. That's significant. Understanding light years changes how you see everything. When you realize the nearest star would take thousands of years to reach, when you grasp that communication with anyone out there would take decades or centuries, when you comprehend that we might be fundamentally isolated by the structure of space itself, it shifts your perspective. The things we argue about, the borders we draw, the conflicts we engage in, all of it happens on one tiny planet in a vast cosmos. From the perspective of Proxima Centauri, 4.24 light-years away, all of human civilization is invisible. Our problems, our politics, our differences, none of it matters to the universe. The stars don't care. The galaxy doesn't notice. Space continues its slow expansion, completely indifferent to human affairs. But that doesn't mean your life doesn't matter. It means the opposite. If we're alone, or effectively alone, because we can't reach anyone else across the light years that separate us, then what we do here matters enormously. We might be the only consciousness in our region of space, the only minds capable of understanding the universe, the only beings who can create art, discover truth, feel love and compassion, and wonder. Every act of kindness you perform, every moment of connection you experience, every time you look up at the night sky and feel awe, it matters. Not because the universe cares, but because you care, because consciousness is rare and precious and extraordinary, because you are the universe's way of knowing itself in this particular corner of space and time. So the next time you look up at the stars, remember what you've learned. Those points of light are not just lights, they're distant suns, separated from us by light years, by distances so vast that the light entering your eye right now has been traveling for years or centuries. You're connected to those stars across space and time, linked by photons that have crossed the cosmic void to reach you. You are small, yes, insignificant in cosmic terms, absolutely, but you are also here, and you are aware, and you can understand what you're seeing. You can contemplate infinity and your own smallness simultaneously. You can feel both humbled and empowered by the same knowledge. And that understanding, that ability to grasp your place in the cosmos, is what makes us human. If this journey through space and time has changed how you see the universe, hit that like button and subscribe. Please share this with someone who needs to remember how vast and beautiful and mysterious our cosmos truly is. Because understanding light years isn't just about astronomy. It's about understanding ourselves. Thank you for traveling with me through the light years. And remember, every time you look up at the night sky, you're seeing across distances that boggle the mind, across time itself, and witnessing the universe in all its impossible vastness. And somehow, impossibly, you're part of it all.